Our solar system is a vast and ordered place. It has 8 planets. They all move in great circles around the sun. The sun sits at the center, a star of immense power. The planets follow a clear path, an arrangement set billions of years ago. From the sun, the order is Mercury, Venus, Earth, Mars, Jupiter, Saturn, Uranus, Neptune. Each planet is a world of its own. Each one has a specific size. Each one holds its own unique place in the darkness of space. Every world follows its own set of rules, governed by gravity and distance. Earth is the 3rd planet from the sun. It is a small, rocky world, a beautiful sphere of blue and green. It is our home. Our world has vast oceans of liquid water and an atmosphere rich with air. Earth spins on its axis once every 24 hours, creating the cycle of day and night. It travels around the sun once in about 365 days, which we call a year. Earth exists in a special region. We call this place the habitable zone. Here, the heat and light from the sun are just right for liquid water to exist on a planet's surface. And where there is water, there can be life. Far away, in the cold outer reaches, is Uranus. It is the 7th planet from the sun. Uranus is an ice giant, a massive world made of gas and frozen materials. From a distance, it appears as a pale, featureless blue orb. This giant sits incredibly far from the sun's warmth. It is about 19 times farther from the sun than Earth is. The sunlight that reaches Uranus is faint and weak. Its surface is brutally cold. Temperatures there drop to nearly -200 degrees Celsius. Uranus has no solid ground like Earth. It is surrounded by a thick, deep atmosphere of hydrogen, helium, and methane. Uranus has another strange feature. It spins on its side, tilted at an extreme angle. This unusual tilt creates seasons unlike anything we know. One pole faces the sun for decades, while the other is plunged into a long, dark winter. It is vastly different from our own. Let us imagine a great cosmic exchange. We will move Earth from its comfortable home and place it in the cold, distant orbit of Uranus. At the same time, we will bring the ice giant Uranus inward, setting it in Earth's 3rd orbit. This is purely a mental exercise, a way to explore the delicate forces that shape a world. To find the answer, we must look at many things: light, heat, gravity, atmosphere, and the fate of life itself. The first and most immediate change would be light and temperature. The sun would appear as a tiny, brilliant star, too small to provide significant warmth. Sunlight at Uranus's orbit is about 400 times weaker than what we receive now. Without that energy, our world would radiate its warmth into space, triggering a catastrophic drop in temperature. Ice would form on oceans, starting at the poles and racing toward the equator. Rivers and lakes would freeze solid. The blue and green marble would transform into a white, frozen sphere, locked in extreme cold. Placed in Earth's orbit, the ice giant would be bathed in intense sunlight, receiving 400 times more energy than it does now. Frozen and stable gases would warm, expand, and churn. The quiet planet would awaken into turbulence and storms. The sun's energy would drive powerful storms and alter the very nature of its atmosphere. 2 worlds, transformed in opposite directions by the same star. Now follow the darkness and deep cold to see how far the consequences go. On the new distant Earth, the consequences of the cold would be absolute. The planet's climate system would shut down. Oceans would skin over, then thicken, reflecting the faint light and accelerating the freeze. Over time, ice could extend hundreds of meters or more. Land would become permanently frozen, mountains drowned in massive glaciers. The greens, browns, and blues of Earth would vanish beneath a uniform white. Life on the surface would face immediate extinction. Plants need sunlight for photosynthesis. In perpetual twilight, there would not be enough light to sustain them. Forests and grasslands would die. With them, the food web collapses. Only deep below, among geothermal warmth, might microbes endure. A thick ice lid could insulate pockets of liquid water, sustained by hydrothermal vents and chemical energy. The atmosphere would undergo a radical transformation. Air, mostly nitrogen, then oxygen, stays gaseous thanks to temperature and pressure. In profound cold, gases lose energy, condense, and even freeze, falling like exotic snows. Moisture vanishes first. Carbon dioxide would freeze next, snowing dry ice. Near -200 Celsius, oxygen turns liquid and nitrogen begins to condense. The sky rains air, the atmosphere collapses. A thin frost of frozen gases coats the surface. Weather ceases. Pressure plummets, Mars-like or thinner. Liquid water cannot persist. It would boil away even cold. The loss of atmosphere seals Earth's fate as a dead, frozen world. Planets closer to the Sun move faster. Those farther away move slowly. At Uranus's orbit, Earth's year would be about 84 Earth years. Earth's 23.5-degree tilt remains the same. Each season, spring, summer, autumn, winter, lasts about 21 years. Spring, summer, autumn, winter. Imagine a winter that lasts 2 decades. Even frozen, the summer hemisphere gets slightly more energy. Over decades, some frozen nitrogen may sublimate, drifting as a thin temporary atmosphere to refreeze in winter. Days remain 24 hours, dim days and dark nights, stacked into tens of thousands of sunrises per season. Our familiar yearly rhythm dissolves. Time itself would feel different on this slow, cold Earth. Closer to the Sun, Uranus heats rapidly. Its upper atmosphere expands and begins to escape. High-energy photons drive photoevaporation. The solar wind strips gases into space. A comet-like tail would trail for millions of kilometers as the planet slowly loses mass. Ultraviolet light breaks methane. Hydrocarbon haze forms, shifting the planet from pale blue toward brownish orange. New and exotic clouds emerge as different materials vaporize and condense at different altitudes. Uranus becomes turbulent and unrecognizable. After millions of years, outcomes are uncertain. If stripping continues, a small rocky core could emerge, creating a new kind of world, a hot, dense super-Earth. The swap would not just move a planet, it could destroy it and create a new world. Planet identity is tied to place. Distance, energy, and gravity write a planet's story. On the frozen Earth, could humanity survive? The challenge would be monumental. No breathable atmosphere, no protection from cosmic radiation. Survival would demand self-contained habitats, built deep underground, using rock and ice as shields and tapping geothermal energy. Heat, light, electricity. We would recreate air and pressure, grow food in hydroponic farms under powerful artificial lights. Water is abundant as ice, melted, purified, and recycled in closed loops. Survival becomes a constant technological struggle against the cold and the dark. A life lived in a bunker, with no view of the outside. Could we ever make the surface habitable again? Terraforming a frozen Earth would require unimaginable energy. Orbital mirrors miles wide, detonations to melt ice, manufacturing potent greenhouse gases, ideas from science fiction. The energy, resources, and time, thousands to millions of years, are far beyond our present reach. Physics and thermodynamics are formidable. The cold of deep space is relentless. Reclaiming an entire planet might simply be impossible. This thought experiment, this great cosmic swap, teaches us a profound lesson. It reveals the extraordinary fragility of our existence. Life is not chemistry alone. It is also an accident of astronomy. We depend on a precise, stable location in the solar system, the narrow habitable zone. Move our world too far out and life freezes, too far in and life burns. Distance sets energy, Size holds air and oceans. Spin and tilt give manageable seasons. Our moon stabilizes the tilt. Giants like Jupiter help sweep hazards. We are part of a complex, interconnected system that has worked in our favor for billions of years. This understanding should inspire wonder and responsibility. Our planet is not just a rock. It is a living, breathing world, a precious outpost of life in a hostile cosmos. The rules that let us thrive are strict. The balance is delicate. Small changes can unravel the tapestry of life. By imagining the cold edge, we see, by absence, everything we have: warmth, light, and life. A planet is more than rock or gas. It is a product of its environment. The cosmic address is everything. What will we do to preserve the delicate balance that makes our home so special? And so is amazing.